Okay, for today, I want to first review yesterday, and then I'm going to talk about what on earth this means. And then we're going to talk about problems. iPhones need to go away at this point. Please don't make me say that again. They shouldn't be out on your desk. You'll be too tempted to check them. All right. You got to remind me to start this assignment with you because the first problem is kind of weird. Okay? All right. So, some review first. I'm going to ask you to add a blank page. Sorry, this morning was a little crazy. I didn't have time to clean this up and make it perfect for you. But I'm using last year's file, which, usually works. But I had 8 million people in here for mass time, and I had a meeting before that. And so it's been just run. All right. So here's the review from yesterday. If I said this is my function, you should be able to say if it's really a function or not just by looking at it. Do you remember what the rule was for looking at an equation? How you can tell if it's a function or not? You can, just by looking at it. If it was a vertical line test, this is not a picture. If it was a picture, I'd use the vertical line test. If it was a graph, I'd use the vertical line test. If it was a set of points, if it was like this point, that point, that point, that point, I would check and see that when you put in a number, like for x, that you only get one thing out for y. Okay, but this is just an equation. This one is a function. I can guarantee it's a function because it's solved for y and there's only one equation. If I had this, it's not solved for y anymore. And so is it automatically not a function? No. You'd solve it for y and see what happens. How would I fix this? How would I solve it for y? So right now it's y squared equals, what do? Square root. And if you don't really know your math, you think that the square root of y squared is y. It is not. And we really need to get this across. I've said it a bunch of times, but I think people still don't get it. They're like, square root of y squared should be just y. But you can't deny that if you graph this, if you were to graph this thing, that whatever the answer to it would, whatever the answer you get as a graph would be the answer. And the answer you get is an absolute value. If you want a graph, you'd have to change this to an x. But y equals x squared, but then the square root of that comes out to an absolute value like this. That means the answer is an absolute value. So this is the absolute value of y equals the square root of x squared plus 5. And what that means is that it breaks into two equations. Y equals square root of x squared plus 5, and y equals negative square root of x squared plus 5. What are these? That's a half circle, and it looks like this. That's a half circle that's been flipped. So it looks like this. And guess what? It makes a circle. The original black one up there, that's the equation for a circle. It has an x squared and a y squared and a radius. Normally we see them like this. X squared plus plus y squared equals like 36. That's a nice clean circle. That's a circle that has a center at 0, 0 and a radius of 6. The point is that if you solve this for y and you get two different equations, and those are different equations, then it will not be a function. I could have known that by just looking at the picture and saying, oh, it doesn't pass a vertical line test. But it's so much simpler to not have to graph it and use a vertical line test. Because if I have this, you can tell automatically, that's a function. I know it is, because it's only got one y equals. If it had a squared here, I would take the square root, and it would not be a function anymore, because that comes out to absolute value of y, which gives you two equations. All right, so next, some points. Is this thing a function? No. Let me ask you this. Is that a function? Why? Yes? This is a function because that's the same point. When you put in 2, you expect it to give you 5. That's okay. That doesn't break any rules. And if you want to prove it, watch. I'm going to graph it and see what happens. I go over 2 and up 5, and then at the same spot is the exact same spot, and then 5, 2, over 5, up 2. Okay, and now will it pass the vertical line test? Yeah, it will. All right, here's another one that throws people off. They think if there's anything weird, then it's not a function. It's not the directions. 2 comma 5, 3 comma 5, 4 comma 5. That's weird, but does it break the rules? That's the question. If I were to graph the points, I can just kind of cheat and use the vertical line test and tell if it passes or not. Over 2 up 5, over 3 up 5, over 4 up 5. Is that breaking the vertical line test? Nope, that's not a problem. The thing is, if you put in an input like 7, it better not give you 2 things. It better not give you 0 and 7. If I put in 7 in the function, it better not have 2 answers. So if I put in a 7 here and it gives me, I don't care, 13. Then I put in a 7 again, it better give me 13. Otherwise, if it gives me something else, it's not a function anymore. It's okay if it gives me 13 again. In fact, that's what it should give me. All right. So there's the rules in telling if something's a function or not. Next thing we got to do is find f of weird things. I know that since you were in higher algebra, this should be easy if I just say f of 5. Don't even write it. Just think about it for a second and then figure out what would that be. Thank you for not saying it out loud, but I know a lot of you know it. What do you think? Say it. 20. All it is take this. Notice me putting in a parenthesis. That's key. Now I'm going to drop in what they told me to. They told me that x was 5, so I stick a 5 in there. So 3 times 5 is 15, plus 5 is 20. All right. How about, what's f of b? I'm not telling you what p is. Write down what you think the answer is and compare it with the kid next to you. I didn't hear much talking. Try. Compare it with the kid next to you. Okay, all you had to do is, this is where x is supposed to be, right? So they basically said that x needs to be p. So put in a p for the x. That's all they're saying. So 3p plus 5. That's it. Raise your hand if you knew that. Okay, good. Next, what is f of, well, I don't know if you remember, but we just did something last test where we figured out f of negative x. We stuck a negative x in the equation. Do you remember doing that? It would test for, do you remember what kind of symmetry that tested for? Y-axis symmetry. Remember we had this? And that tested for y-axis symmetry. How about this? What did this test for? X-axis symmetry. And what'd you do to test for origin symmetry? All right, good. And if I drop in a negative x in this function, I'm testing for y-axis symmetry. I'm going to drop it in 3, and where do I drop it in? The empty spot. Okay, so I drop it in there, and it's 3 times negative x. Oops, sorry. 3 times negative x. And then I multiply it out, and I get negative 3x plus 5. Is this the same as the original? No. So did it have y-axis symmetry? No. And all we did was answer the question, what is f of negative x? And it is negative 3x plus 5. All right. I'd like you to find f of negative p. That isn't the test for anything, but we can tell you to stick negative p in. And it always starts with an empty spot around the variable. And then I just drop in whatever they say. They said to stick in negative p. So here I go. Negative p, negative 3p plus 5. Raise your hand if you had that one right. Okay, good. Now how about if they get more complicated? Like, for instance, f of x is 8. Well, then you can't stick the 8 in, that's for sure, because I didn't tell you the x. But would you agree that f of x is this, and f of x is that, then this must be equal to that. And you could figure out what x has to be then, right? Notice they told me that the y was 8, and they're asking me to figure out what x is. So again, I could either think of this two ways. I could take this 8 and stick it in right there for f of x, or I could just say that's equal to that. 3x plus 5 equals 8. Subtract 5 from both sides. 3x equals 3. X equals 1. Cool. So basically they said, what if y was 8? And you're saying back, well then x would have to be 1. Why? Because if I put a 1 right here, it'll work. It'll make 8. All right, so let's do another one like that. Let's say f of x is now 2x squared plus 5. Would everybody please figure out the answer then for not f of 1, that'd be too easy, not f of a, that'd be too easy, it'd just be 2a squared plus 5. But f of x is 12. The answer is weird. It's the square root of a fraction. So f of x is 12, so I'm putting a 12 right there. And then I'm solving. Subtract 5 from both sides, and I get 7 equals 2x squared. Divide by 2, divide by 2. 7 halves equals x squared. Can I just stop right there? No. What should I do next? Square root. Square root. Square root. What's the square root of x squared? Is it x? No, it's not. What is it? As the value of x is root 7 over 2. So then I got two answers. I split this into two parts. Split, and it becomes x is root 7 over 2, and x is negative root 7 over 2. And yes, you could say plus or minus root 7 over 2. Okay. Now, a typical question in calculus uses this thing that we had at the very beginning. F of x plus h minus f of x. Well, f of x is easy because they'll always give you that. Not always, but in the beginning they will. Okay, so if they tell you f of x is like 2x plus 5, then this part's just 2x plus 5. But what the heck is f of x plus h? Well, let's just do another one like that. Let's say f of x was 2x plus 5. What is f of x plus h? Just stick in x plus h into the equation. Keep plowing through these with me. We're not going to be at this for too much longer. Stick an x plus h into the equation. Did you get 2? Notice empty spot. We always start that way. And then we drop in whatever they say. X plus h. Do I have to actually multiply it all the way out? Yes, you do. You want to simplify it all the way down. So this will be 2x plus 2h plus 5. And that's it, because there's no like terms, so I can't actually simplify it any further. Raise your hand if you had that one right. Okay, good. So what if that little formula is f of x plus h, which we just did, plus f of x, and then when you actually do it in calculus, it's all going to be divided by something, but I'm not going to mess with that yet. We're just trying to show you, here's how you might be asked to do more complicated functions, where you'd stick in x plus h. All right, so now, If I have to take this and then I have to add f of x to it, that's this original. Now would you have some like terms that could be added together? If it's this was f of x plus h. Now I got to add this. Yeah, the 2x can go together, and the 5's can go together. And so you'd have a total of what? 4x plus 2h, and then a 5 plus 5 plus 10. That is a typical problem for today. All right, moral of the story. Got to be able to stick weird things into functions, like negative x, or like x plus h. And from yesterday, you had some rules on how to find if something was a function. All right, there's not too much left to this chapter, but there's one more weird kind of problem that we need to get to. So everybody arrow down or slide down or however you do that. Here is the one we just talked about. Here's an example of one where you'd be asked to find a bunch of things for this function. Here you'd stick in 3. 6 plus 1 makes 7. Here you'd stick in 4x. Here you'd stick in a minus 4. And here you would find f of a and then subtract 4. That's the only one I think you might have issues with. But I'd like you to answer all those 4 right now on your iPad. You may need to zoom in. I know it's kind of small. I'll pause for a second while you do that. Okay, let's see if you did them right. F of 4x, I stick 2 empty spot plus 1, and I stick in a 4x. Did you get 8x plus 1? Raise your hand if you had that one right. Okay, good. Next one, I'm going to stick in a minus 4 into this empty shell of an equation. And I put in a minus 4. And then I get 2a minus 8 plus 9, or plus 1. 2a minus 8 and plus 1 makes minus 7. 2a minus 7. Raise your hand if you had that one right. And the last one, f of a, which is just 2 empty spot plus 1 and drop in an a. 2a plus 1. But then they want me to subtract 4. 2a plus 1, subtract 4, is just 2a minus 3. Raise your hand if you're good with those. Okay, good. That's basic function stuff. Now, let's talk about this. This is the weird kind. Now remember, we were talking about whether things are functions or not, right? This is our function, but we've got 2 variables in there, which makes it a little weird. Do we agree that if it had just been y equals x minus 5, it would have been a function? For sure. Okay? Because it's solved for y, and if it's got one equation for y, it must be okay. But we don't know what a is. We just know that a is, well, what do we know about a? A is bigger than 0. So let's make something that's bigger than 0. Like what? Like 1. And x also has to be bigger than 0. Now that's a bigger deal, because on this xy graph, here's x, here's y. Do you agree that x being bigger than 0 means that all of this area here is possible then for my x's? Those are all things where x is bigger than 0? All right, so let a be an easy value. We stuck in 1. Next, sketch the function. All right. Can we sketch y equals x minus 1? I hope you can. Do you remember the slope-intercept thing? Okay, so make a sketch of y equals x minus 1. It's just a little tiny graph. If you've forgotten it, I'm a little sad, but I get that you might have. I'm going to put a 1 there to remind you what the slope is. Make a sketch. Y equals x minus 1. If you have to, you can always make a little xy chart and find some points. But I hope you remember the slope y-intercept thing. Remember the y-intercept -1 means we start there. Does that ring a bell? And then we have a slope of 1, which means it's going to rise 1 and run 1 and rise 1 and run 1, and it goes like that. There. There is your graph. Raise your hand if you had that one right. Thank heavens. Being an honors pre-calc, I know it's been a while since you've seen mx plus b, but that's your most basic kind of equation. So we did that. Check mark. Next step. Look for intercepts and vertices. Okay, well, this thing doesn't have any like high spot or low spot. Like if this was a parabola, that would be important, right? So what are the important spots? Well, I guess it hits here and it hits here. Now, we made this one up by picking A as just being 1. Do you get that was basically picking the y-intercept to be 1? We had a choice of all the numbers that were bigger than 0. What's something bigger than 0, but not quite 1? Like a half. Do you get this? The graph could have been a little bit higher, but it couldn't have been there, could it? Then I would have had a y-intercept of 0, and it wasn't supposed to be 0. It's supposed to be bigger than 0. Do you get that this graph is kind of where it needs to be, or it could have been here, or here, or here, or here, or here, or here, or here? See what I'm saying? So this is the family of graphs that it could have been. It could have been there, could have been here, like not quite touching 0 at that first one. And then a little lower, and it could have been a little lower, and it could have been a little lower. All right, that's my whole family of graphs. And now, if I'm supposed to find the domain and range of this, just the blue one here, that's not going through 0, it's just a smidge below 0, what would the domain and range of that blue one be? Well, the domain is how far left it goes and how far right it goes. How far does the blue one go to the left? Well, this arrow indicates it goes forever to the left, and it goes forever to the right, negative infinity to positive infinity. And the range of the blue one? How low will it go to how high will it go? What's the lowest that the blue thing could ever go? Negative infinity. And how high could the blue one ever go? Positive infinity. All right, there is the domain and range of the blue one. Now, if I move it down a little bit, I need you to just assess, could this have changed its domain or range if it had been like here? Would it have had a different domain or range? No. You get then that this function, with all these little rules attached to it, means that my domain and range wouldn't have changed. All right, now what's the one thing we never dealt with? In this problem, it said something and I never said anything about it yet. Yes? What about it? Because it has a minus here, and if we're subtracting a positive number, remember that minus is not part of the variable. We've done it right so far except for one little thing, and it's not about the fact that we picked 1. We could have picked a 2 or a 3 or a 4, and that minus would still be there. So if I pick a 5, it's still minus 5. All right. That's okay to do, and that's what made us have to like go lower and lower and lower, and we don't know how low it would go, but all my family of graphs would kind of look like this except for one thing. What haven't I talked about yet? Right there. X has to be bigger than 0. If X has to be bigger than 0, doesn't that change what's possible? Do you get that if X has to be bigger than 0, none of that could exist? So now what's your domain and range? 0 to infinity for the domain. How about the range? What's the lowest this thing could go for the range? Can I keep going lower and lower and lower and lower? So doesn't it go to negative infinity still? Yeah. Do you think about it? Do you think the x would affect the range? No, x is for the domain. All right, I know these are kind of weird. You got to think them through. When you're done, you're going to get like a family of functions like this. So you won't know, except you know it can't cross this line right here. Why is it not going over here? Because it said x has to be bigger than 0. And if right at that line is where x is 0. So can't cross this little divide. You'd have to stay over here. But the family of functions could go as low as we want it to. So now we have to look at that and say, based on all of those, my domain always would be from 0 to infinity. And my range could go as low as negative infinity, all the way up to what's the highest we'd ever go? Positive infinity. All right, that's how you find the domain and range of a complicated function, and yes, you'll have to do that on the test. Here's the simple way. Just make a graph, pick a simple number for the A, like it could be a 5, that'd be fine, but pick a simpler number even, maybe like 1. And you graph the thing, and then this, if they tell you X, they've just told you the domain. The X is the domain. So as soon as they say X has got to be this, well then, you know that is going to be a domain thing. That right there changes your domain. All right, let's look at another one like that in the homework. Here's our first problem of the homework. Can you guys remind me, being a masked day, I'm going to pause for a second while we figure out what time we're out of here. Okay, so we're starting on the homework here, and it says, ooh, this looks a lot like the one we just did together, doesn't it? Isn't it identical to the one we just did together? Is it or not? Oh, it's got one tiny little change. What's different about it? X has to be less than 0. Okay, so this will be very similar. What was the first thing in the little directions? You can always scroll back up and see what the first thing was. What did it say to do? Pick an easy number to put in for what? For A. A's got to be bigger than 0. What's an easy number that's bigger than 0? 1. And now it's y equals x minus 1. Can you graph that? I hope so. There's y equals x minus 1. And then could it have been like minus 2 and minus 3 and minus 4? Yep, so make a family of them like this. And then you say to yourself, well, the domain and range of that would have been negative infinity to positive infinity. But the one last thing you look at is this and say, that's going to chop off half your graph. And that will change your domain and range. So at the end, they want you to sketch it and then find the range. Doesn't even say to find the domain. Okay. Find the range of the following relations, it says. Does that mean it's not a function? Nope. That's like saying shape. It's just not specific. It doesn't say it's a square or a rectangle. Okay. A relation is anything that's on a graph is a relation. Just some of them are functions. So this one happened to be a function. All right, moving on. All it wanted, since the directions aren't here, we have to go back to the last directions, was the range of these after you sketch it. That's why you got the graph paper there, is to sketch it. All right, so let's start by sketching it. What did they say to pick first to make your life easy? Pick an easy number for what? For the A. Okay, so let's pick an easy number that is bigger than 0. Okay, so 1. Put in a 1 here and a 1 there. And can you graph for me 2 root x minus 1 minus 1? Now, in case you've forgotten what that looks like, that's a square root that has been shifted and stretched. We do not have to be perfect on this, but I know some of you are going to be just totally lost on what that looks like. You know what will always save the day? The XY chart. You can always graph a bunch of points, and then you'll start seeing where this graph goes. Do you get, if I started graphing a bunch of points and it started looking like that, you'd be like, oh yeah, it's that like check mark looking thing. This is what a square root looks like. Then here's my square root graph, except shifted to the right one. And then here's my square root graph that's been shifted down 1. And then here's my square root graph that has been doubled on its height. Remember how that makes it twice as tall? There. Generally, it's going to look like that black one. Now, do you think I need perfect points to figure out my domain and range? No, I don't need perfect points. But do you get that this point right there would be critical? Because that one tells me how low it goes. The lowest it goes is this point right here. So I better figure out that one, make sure I got that one right. But other than that, I'm okay with a sketch. You don't need to have the super accurate. All right, so generally it looks like that black one. Let me get the blue one out of there. And now you tell me, what's this domain and range? Well, actually, it doesn't even ask for the domain, so let's just worry about the range. The range is how low can you go to how high will it eventually go? And this looks like, the way I drew it, looks like it like stops at a certain height. It doesn't. It just rises really slowly forever. So, looking at that graph, what's its domain and range? What's the lowest it goes? -1. And then it just keeps going up forever, right? There you go. That's how you get its range. If you don't have a picture, you won't be able to get the range. You've got to make the sketch. That's why we have the little graph over there. These ranges cannot, I can't, even as a math teacher, I can't look at that and just go, oh, I know the range. I have to draw it, at least in my head, I have to sketch it. And then I have to look at that sketch and go, okay, this is what it looks like. So if it looks like that, what's its range? And then I'll answer the question then, after I got the sketch. All right. So I have started that one for you, and the other one, and then this one. These are the toughy weirdies. Then there's a whole bunch of these easy ones. So I think they're so easy that I'm going to cut out the easy one here and just save a bunch of time. Cross off that one. I'd like you to do this one, though, because it'll bend your brain a little bit, because it just says f of x equals 6. Hint, isn't that just the same as saying y equals 6? How do you graph y equals 6? Can you picture the graph of y equals 6? I can picture it. If you can't picture it, you better type it in your calculator and graph y equals 6, okay? For me, the other thing you can always do is one of these and try it, and then you get a bunch of points and be like, oh, yeah, that's right. And then they want to know f of 3. Well, the y is still going to be 6. Do you get that the y is always 6? All right. So I'm going to let you play with that one, and once you get a bunch of points on it, you know, like up here, I hope you'll start to get the idea of, like, let's say this is where y equals 6, which is not right, but let's say it was. Then you can get your other answers from that. Okay. Moving on. This one. They want you to find f of 0 and f of x equals 0. That is code for if x is 0, they're asking you to find the what? Y-intercept. By sticking in x is 0. And then this one is saying that y is 0, so really they're asking you to find the x-intercept. All right, so do that for these two, and then that's enough. We can skip that one. Okay, so really they're just asking you to find the x-intercept and the y-intercept on these. The x-intercept, you stick in y is 0. The y-intercept, you stick in x is 0. All right, one last thing. You're looking at this, and they ask you to do stick in x equals 0. Some people just think, oh, so everything is 0. No, that's 0 and that's 0. What's 0 minus 0? Can you have 0 on the top of a fraction? Yes. You can't have a 0 on the bottom, but is the bottom actually equal to 0 here? No, it's not. So you're okay. One last thing for honors pre-calc. You have to know the difference, that that's equal to 0. That is called undefined. Ah, that's terrible. You can't read that. I'm going to say no solution. It's not actually the same thing. Technically, it's undefined. But that one's bad. This one's okay. Totally okay. Does it have a 0 on top? It just means the answer is 0. So when you stick 0 in this, I don't want you to freak out when there's a 0 on top. It's okay. All right. That's all I got for you for the video for today.